Hey there, everybody. Welcome back. We are looking at section 2.4 in John Blakely's textbook. This is the Linear Inequalities and Interval Notation section. So in this section, we've done inequalities, the less than, the greater than, the less than or equal to, the greater than or equal to. Now we did them with just numbers. Now we're going to have variables. So I could have something like x less than 4. Maybe I'll call that A, and we'll show these on a graph. X is greater than -5. We'll call that B. X is less than or equal to -2. We'll call that C. And X is greater than or equal to 3. We'll call that D. So if I have a number line, and I'm just writing out -7 to 7 on the number line. X is less than 4 means it like 3 is less than 4. 0 is less than 4. Everything up to 4, but not 4. 4 doesn't work. 3.99 is less than 4. All the way up to 4 and less than it. Any number to the left of 4 works, but not 4. Since 4 doesn't work, I'm going to put a circle on 4, but make it hollow. I'll call that line A. X is greater than -5. -5 is right here. We want numbers that are larger than -5. They are to the right. And I'll call that line B. For C, we have less than or equal to -2. -2 is right here. I'm going to do these underneath it now. Since we can include -2, we're going to use a solid point here. And we want values that are less than it, which are to the left. That would be C. And finally, values that are bigger than 3, including 3. We start at 3, we fill in the circle, we go to the right. Now the computer will do, I did these above and below it. It kind of makes it easier to see. The computer will do stuff like this. For D, they'll put it right on the graph. And if you can see in color, it's easy to see. Sometimes it's not always thick enough to notice. And in black and white, with a black line underneath, it's really hard to see. So I think doing them above or below is most helpful. And that's how inequalities work. What about interval notation? So interval notation has some rules. I'm just going to write the notation for each of these. Now, yeah, I am. I'm going to write the notation for each of these, and then we'll discuss what makes them so. So A is -infinity to 4. We have parentheses on both sides. B is -5 to +infinity. It's got parentheses on both sides. C goes from -infinity to -2. We have a parentheses with the -infinity, and the -2 gets a bracket. And finally, D starts at 3. It gets a bracket, and it goes up to +infinity, which gets parentheses. I'm going to do a third range or fifth range real quick. We're going to call this range E. E is going to be -1 is less than X, which is less than or equal to 2. Which would be this region right here. And if I do E's interval notation, I have -1, 2 in brackets. So the way interval notation works is we're putting things in place the start and stop inside grouping symbols. Start, stop of an interval inside grouping symbols. In order. So we have start, stop. I think with the -1 and the 2, it was the easiest to see. This is saying X is between -1 and 2. Okay, so we started at -1, we ended at 2. I used different grouping symbols there. So the way we choose the grouping symbols is use parentheses for the left side or right if the number is infinity plus or minus or not included. So everywhere I had an infinity, you'll notice I have a parentheses. Infinity is all the way to the left. Positive infinity is all the way to the right. It is not an actual number. It is a concept. There is no number because there's infinity is the largest number possible, but if we gave it a value, we could always pick a number, that number plus 1 and have a bigger value. So it's more an idea. Then for points that are not included, which not included is very much with less than or greater than only. So on A and B, I had less than and greater than. The 4 and the -5 both got parentheses. On my, this is called a compound inequality. The -1 had a less than, so the -1 got a parentheses. If you take a look at it, you can see the other ones where the values were included got brackets. So use square brackets if the value is included. And that comes from less than or equal to or greater than or equal to. So those are our rules. We can do normal problem solving steps to get these. I'll just do a quick one on here to illustrate the idea. I'll do the examples in another video. They work just like equations. You're going to replace the equation, or you're going to use the inequality symbol first. Actually, there is one more rule for solving, so maybe I need to do that here. In the rules section of the video, So solving inequalities. Solve them like you would in an equation. Except for the following caveat. If you multiply or divide by a negative, flip the inequality. Simple. There is one more thing that does flip the inequality symbol. If you swap sides, but don't do addition and or subtraction to do it, flip the inequality. So I'm going to use that x was less than 4 thing to show this last example. If we had x was less than 4 and I wanted to switch it so that I had 4 on the left and x on the right, the alligator mouth, the vampire, is chasing the 4. So it needs to be chasing the 4 over here. So notice that I flipped it. Instead of it being less than, now it's greater than. An example of A real quick. If I have negative x is less than 4, I'll say 14. If I want to, or if I divide by a negative, this becomes x. This is negative 14. This has got to be greater than now. So for example, you can see here, like if x is 2, negative 2 is less than 14. And also over here, 2 is greater than negative 14. It's just showing you that it does work. Those are the reasons to flip the inequality. Other than that, we're going to solve them like normal. And I'll stop this video with the instructions. We'll do the examples in the next video. Peace.